Hello friends, welcome to your channel, Learning with Gustavo. Today we are going to talk about him. Operational amplifier, widely used in electronic instrumentation. Accompany me to the end of the video to see many important aspects of this electronic component. An operational amplifier, or also called open, is a component, electronic, that helps us amplify signals. This component is widely used in instrumentation, also to amplify sound and everything that has very strong signals, small entrances that need to be amplified. We can find encapsulated with 1, 2, or 4 operational amplifiers in your interior. In the image we see the scheme of an amplifier. Operational, we have 5 terminals. Connection to our power. This we can do with a simple font or with a symmetrical font or dual. Then with respect to ground, we can have 5, 9, 12, 24 volts, maximum 30 volts. This if we feed it with a source. Simple 2, if we feed it with a symmetrical font, we can have 5 to 5, 9 to 9, 12 and 12 and 24. 24 we have an output terminal where to give us the signal amplified, and we have 2 terminals of input. These 2 input terminals correspond to the signal input that are we going to amplify, or what are we going to compare. We find a terminal inverting input and a non-terminal inverting the non-inverting input. We can also find it as positive and inverter input. Negative, we had already said that a operational amplifier basically what it does is compare. Then what compares are the 2 inputs, and based in the input voltages we will deliver a voltage of output. In this example we have a powered operational amplifier, 15 positive volts and 15 negative volts. We can also find it as positive and inverter input. Negative, we had already said that a operational amplifier basically what it does is compare. Then what compares are the 2 inputs, and based in the input voltages we will deliver a voltage of output. In this example we have a powered operational amplifier, 15 positive volts and 15 negative volts. Here we see another example. Op-amp is powered with 5 volts and GND 5 volts and ground. In this case, if the inverting input is higher at the entrance, no inverter at the output, we will have GND or ground, and if the inverting input is less than the non-inverting input in the output, we will have the 5 volts of feeding. We can see this better with an example in ProTunes, so let's go to. Here we have an amplifier. Operationally we are going to use it as comparator, and we are going to feed it with a tension of 12 volts. At the inverting input we have 2 10K resistors. This forms us here. We have a divider voltage. If the 2 resistances are equal in the inverting input, we are going to have 6 volts. We can check that with the voltmeter that we have installed. The inverter input to land on the other side at the entrance, no inverter, we have a potentiometer 20K. We also have a voltmeter for check what voltage we have on each moment. Is this 20K potentiometer is going to give us a variable input and in the output, and at the output we have two LEDs, each polarized with a resistance of 1K. Let's see it in operation. We give play to the circuit and we have in the inputs on the inverting input. We have 6 volts and at the entrance there is no investor. We have 4.08 volts and at the output we have the LED green. The positive is less than the negative, so that's why it's on the green LED. Now the green LED went out and the red LED turned on. We have in the inverter input the same 6 volts. On the non-inverting input we have 9 volts. Here it will give us inverted. If we have the positive greater than the negative, is going to turn on the LED red, because since the red LED is the one that goes to GND, then the output is positive. Now let's do the change. Now we have 1.68 volts. If we lower the voltage at the output, no inverter, at the inverter input, we have the same 6 volts, and at the input non-investor we have 1.68 volts. And how the output should give us ground or GND, the green LED is going to go turn on, which is the one that is polarized with positive. When the positive is on top of the negative, it will give us positive at the output, and when the positive is below negative, it's going to give us a negative result. Exit. Well then, at the entrance inverter we have 6 volts. At the input no inverter we have 1.68 volts. When the negative input is greater than the entrance positive, the output will be negative. And how we have the LED cathode green connected to the output and the anode connected with a resistance that goes to 12 volts. For that reason, this Well, now we pray a voltmeter at the output. Let's see what result we delivery we have. In the positive input 11.5 volts, and at the negative input we have 6 volts. At the output we have 10 volts. We are going to vary the input positive 10, 9, 8, 6.84, 5.88, and we changed. We were left with 2 volts. Exit. When it changes to exactly the output remains at 10 volts. 6.12. And when it drops below 6 volts, that is, when the positive input remains under the entrance negative, the output lowers the voltage. No, we have exactly 0 volts or GND left, but it does give us a voltage with which we can turn on the LED that we have connected to positive. The output voltage is not exactly, because we are using the operational amplifier as comparator. We just don't have any connected resistive component is alone, just like comparator. In this case we are using with the 12 volts, but if we connect it with a source, symmetrical is going to be exactly equal. That's all friends, I hope you serve the video. Don't forget to like it. Video, subscribe and click on the bell for YouTube to notify you every time a new one is uploaded. Video.